7.2 properties of exponential functions. So we already talked about growth and decay and what the difference would be. So if for some reason we have a number in front, like this A, kind of like the last note that we did. If we have a number in front and stretches it out. So if you compare, like this is my parent function, this is that same function, but now I'm multiplying by 3. If you notice that this was my parent function and a number out in front would stretch it out, so it would move up faster. So if I'm going to be graphing something like this has two different transformations. This right here will flip it. So a negative out in front will flip. This right here is going to compress it. Up here, stretched out faster, but now because this is less than 1, my a value is less than 1, it should push it down. This is my parent function. That's my parent function. So first thing I'm going to do is type it into my y equals, I'm going to go to my table. So second graph to get to my table. Remember that point, 0, 1, but now here it's going to be 0 and negative 1/3 because of the a value. I'm going to write down my table, and now I'm going to plot my points and graph. So when I look at my graph, it's still going to be a growth because on the right-hand side, it's moving away from my x-axis, and on the left-hand side, it's going to my x-axis. When I'm looking at this, my horizontal asymptote still will be at 0. There's no way that we're going to make it to 0. So my domain, even though it doesn't say this, will still be all real numbers. We can put any number into that. My range is going to be, my graph is below the line because of this negative right here, not because of the 1/3, because of the negative, it flips it, so it's going to be less than 0. Again, my asymptote will be a horizontal, asymptote at y equals 0. You try to graph this one by yourself, knowing that this right here is my parent function. So anything that happens to this right here is going to be a transformation. So it should look something like this. My domain here would still be all real numbers. My range here does not go past this asymptote, so it'd be y, and because of that negative, it flips it. It's y is smaller than 0. My horizontal asymptote would be y equals 0. One thing to know here, because of my parent function base is 5. That's why this moves up so fast, is because my parent function, the 5, moves it up fast. If this was a parent function of 2, it would not move up as fast. So your parent function will also be an indicator of how steep this is. So now when I'm looking at this, now I have other types of transformations. This right here is still my parent function. Notice how this is going to be moving, or this is just with the x value. Now we have had multiple different graphs in the past, and whenever there is a add and subtract with the x value, it moves it left and right. So I'm assuming because this is going as opposite, this will move right forward. So I have to figure out what's moving right forward. So if you type into your y equals, go to your table. Right here, got a lot of decimals. But we have this point right here. Typically, when we type 0 into our parent function, we get 1 out. But notice how now when we type 4 in, we get 1 out. So really, it's just going to move the whole graph to the right. So that normal point that we start with at 0, 1, now is going to be shifted to the right. So if I write down my table, so here's my table. Noticing that this is what moves to the right. So this point typically is here at 0, 1, but now it's shifted to the right 4 because of this, so that original point. And now it still doesn't, though it still hugs that x-axis. So my domain here is still, I can put any number in. My range here, it's above it. So y would be greater than 0 because this right here, my horizontal asymptote would be y is equal to 0. Right now, the first thing that I notice for this one is that this is going to be a decay. I know my a value is really going to stretch this out a lot. And then I also have a minus 10. So if I plug this into my calculator, right here, I know that this is going to move it down 10. We have to try to figure out what's moving down 10. So plug into your calculator. Looks like this. I'm actually going to graph this first. When I graph it, you can see that I actually can't. Oh, here it is. There. So this is what the graph should look like. So one thing you should be aware is that this is a 10 by 10. So all these tick marks are by 10. So it looks like this moved it down. So it is still decay because on the right it's going down, on the left it's moving up, but it looks like it moved this whole thing down 10. That's getting really close to negative 10, but not actually hitting it. So now if I go to my table, second graph, I know that my y values are right here, should be able to help me graph it. So find your table and graph. So you can kind of see my points here. Now, one thing, even when you look at your table, look at how it gets really close to negative 10. It says it's at negative 10, but it's not actually getting there. It's getting super close, but never actually passing that point. Why? Because that transformation, that minus 10 at the end, is changing my horizontal asymptote. So what changes up and down? This transformation right here will change your horizontal asymptote. So this right now is where my horizontal asymptote will be. So my domain is still going to be all real numbers. I can plug any number into that equation. My range. Now this is the spot, right? Your horizontal asymptote is where I'm going to be focusing on, that negative 10, that down 10. It's above that point, so y is greater than, not equal to, because my horizontal, asymptote is at, I don't know why I'm writing funny, negative 10. That says negative 10. So now if I just give you the equation and you have to say, what is the transformation? This right here is my parent function. So I just have this add or subtract with my x value. When you're adding subtracting with your x value, that's always going to move it left and right. Remember, with the x value, it's always opposite. So this would actually move, the whole thing would move left too, because it's opposite. So right here, this is my parent function. Anything that is raised to the x value, that's the parent function. So the 5 is going to stretch it. So it'd be a stretch of 5. There's no ending subtracting here, no negative. This right here is going to move it up 5. So that's my transformation. So now what if we don't have an equation, but we're given this information right here? We can go into stat. So if you push your stat button and you want to edit, push enter, you're going to edit. So if you wanted to clear these out, you would highlight that, push clear, do not delete. Push clear, you would arrow down, that whole list is gone. Your L1 will be the time, your L2 will be the temp. Now I want to get an equation from this. So if I go back to stat, this time I'm going to arrow over to calculator. And we've done all of these before. This one we have not done. This is exponential regression. Basically, it's going to say, I'm going to give you, based off these data points, an equation that would symbolize this information. It tells you what your A value is, and it tells you what your B value is. So my equation would be y equals, my A value is 196.6572, each round to the nearest 10,000. And then times my B value is 0.977. That would round to 6 raised to the x value. So I know for sure it's going to be decay. If I check this as I get larger, as the time gets larger, the temp does go down. This is asking the best temperature to group is, the table shows the temperature reading the sample cup of coffee. How long does it take for a cup of coffee to be cool enough to drink? So if I'm looking at this, cool enough to drink, it says is 185. So that's my F, that's my temperature. So what I want to do is go into my y equals, now I can type this equation in, 196.6572 times, and then 0.9776 raised to my x value. So my temperature has to be 185. So if I now go to my table, so I go to my table, where is this 185? Right here. So it'd be after 4 seconds, 4 minutes, because my units here is minutes. So it'd be 4 minutes. After 4 minutes, be cool enough. How long does it take for the cup of coffee to reach 100? So again, if I go down here, 100 degrees Fahrenheit. Got somewhere to go. Still going. Oops. So right here, I would say 30 minutes. Ooh, that's a long time. If for some reason you don't want to arrow back up again, you can go back to your, right here, this table set, right there. So if I go second, right here, I'm going to start now at 0. And now if I go back to my table, now I start at 0 instead of 23. So the last bit of 7.2, we're introduced to the natural base exponential function, e. E is a number just like how pi is a number. It's an irrational number. It goes on forever. So we can evaluate this into my calculator. So if you look at this, my E value is right above this natural log, so right there. So I can push second button and then there. It's going to be raised to the third power. So this answer, I should round it to the nearest 4 decimal spots. So you should try e to the 8th by yourself right now. As you do, you should get 2,980.957. Oops, this 8 will round this 9 up. So this is actually going to be 8, 0. You have to include that 0 to say that you already rounded. So at some point when we talked about how to compound interest, we also have an equation when we're compounding annually. So the interest is continually compounding throughout that whole time. So every night it would keep on compounding. So this would be if you only got the interest every year. This is compounding every single night. So this would be much better. And that would be this equation. So depending on what your time is, your P is your principal, what you start at. You use E, that number, and then you always have your rate times your time. So it's called PERT. So how do you know if you should use PERT? If it ever says compounded continuously. So it's saying that you deposit $3,000, that's going to be your principal. That's this P value. Pays 5% interest, so times E. My rate, you have to change this. My rate, you have to change to a decimal, so it'd be 0.05. And it's asking for 4 years times. Should be times in between there. 0.4. So if you type that into your calculator, 3,000, and then your E value, and then 0.05 times 4. To the nearest dollar, make sure you're reading directions carefully. So to the nearest dollar is going to be $3,664. Dollar bills, yo. Next question says 4 years of high school. How much will be in the account after 4 years of high school? So starting in 5th grade, you have 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. You have 8 years. So that's saying 8 years. Same equation. So still 3,000. Your rate is still 0.05. This time is times 8. Again, you could retype it all in. I'm going to go over here and just change my 8. And there would be 4,475 dollar bills. Yo. And there you go. 7.2. Like a glove. Fits like a glove. Have a great day.